Now in this lesson, we're going to learn to perform calculations with two new terms. They are percentage yield and percentage purity. Now the first term that we're going to look at is percentage yield. Alright? Based on the word yield, what does it mean to you? For many, it may be how much you are getting, or how much is obtained, or how much is produced. Okay, so that is the meaning of yield. Alright, so based on that, let me bring you back to one of the calculations that was performed in the previous lesson. In the previous lesson, we were looking at this particular reaction, and we have performed calculations and found out that in this reaction, okay, the mass of product that we will get is 101 grams. Now if we were to perform this reaction, in real life, the mass of the product that we get may not be 101 grams. Alright, it may only be, let's say, 90 grams. Okay, why is that so? Because sometimes your reactants may not react completely. Sometimes after your products are formed, they can undergo other reactions to become something else. Alright, so the actual mass of the product obtained will not be exactly what you have calculated. And all the time, or almost all the time, it will be lesser than what you have gotten. Alright, so if you were to take this as a mathematical problem, percentage yield, I'm sure many of you all will be able to tell, it's actually 90 over 101 times 100%. Alright, so in any chemical reaction, in order to find the percentage yield, is actually equals to the actual mass divided by the mass that we obtain from calculation. We call that the theoretical mass, times 100%. Alright, so this is how we perform calculations to obtain percentage yield. Okay, as mentioned, percentage yield is the actual mass of product which we obtain in a reaction divided by the theoretical mass, which is calculated based on the amount of reactants. Now in 90% of the questions involving percentage yield, the numerator, meaning the actual mass of product, is given in the question. Alright, so this value will be given in the question, and then the theoretical mass, that means the mass of product that we should be getting, must be calculated based on what? Based on the amount of reactants. Okay, now with that in mind, let us look at a particular question involving percentage yield. Right, I'm going to give you all about maybe 10 seconds to read the question. As you are reading the question, just a reminder that in a percentage yield question, the actual mass, or 90% of questions, the actual mass is given in the question. Okay, so as you are reading, if you see this part, 48.8 grams of urea are produced. Alright, so this is actually your actual mass. Okay, so we have already gotten the actual mass from the question. Now we need to obtain the theoretical mass, or the mass that we calculate based on the amount of reactants. So let's look for the amount of reactants when 1 mole of carbon dioxide reacts with excess ammonia. Okay, so the question tells you that you have 1 mole of carbon dioxide. Now we need to find, based on this 1 mole of carbon dioxide, what is the mass of urea that we can obtain. Right, so first and foremost, we have to make use of the 3C approach again. Alright, step 1, convert to moles. There's no need to perform that step because in this question, the number of moles of carbon dioxide is already given to you. Step number 2, compare mole ratio. Compare mole ratio between what is given, which is carbon dioxide, and what you want to find, which is urea. Alright, as you can see, number of moles of urea is actually equals to number of moles of carbon dioxide, which is 1 mole. Step number 3, convert from moles. So now we need to find the mass of urea. And how do we find the mass of urea? Is taking number of moles times the molar mass. So 12 plus 16 plus 2 times 14 plus 2. Now this mass that we have just calculated is your theoretical mass. It's the mass of urea that we're supposed to get should all your carbon dioxide undergo reaction. Alright, so now we have gotten the actual mass, we have gotten the theoretical mass. The last step to be done is to find the percentage U, which is the actual mass divided by the theoretical mass times 100%. Alright, and that will give us a percentage U of 81.3%. So before we go on to look at the next term, which is percentage purity, just a reminder, percentage U is equals to the actual mass divided by the theoretical mass times 100%. In 90% of the question, the actual mass is given in the question. Alright, and we need to find the theoretical mass. To find the theoretical mass, we need to look at the amount of the reactant given in the question, and based on the amount of the reactant, when we use the 3C approach, we can find the theoretical mass of product that will be formed, and percentage U will be just equals to actual mass divided by theoretical mass times 100%. Now the next term that we're going to look at is called percentage purity. Now imagine if I have a sample of impure calcium carbonate, right? Meaning calcium carbonate contaminated, mixed with something else. Alright, and the total mass of this pile of solid is 100 grams. Okay, now based on some subsequent experiments, I found out that out of this 100 grams of impure calcium carbonate, only 90 grams is actually calcium carbonate. So what is the percentage purity? Again, this is like a mathematics problem. So the percentage purity of calcium carbonate is 90 over 100 times 100%. Okay, so in chemical calculations, to find percentage purity, we take the mass of the pure substance, okay, divided by the total mass of the impure substance. Alright, I'm not saying the mass of the impurities, but the total mass of the impure substance times 100%. So this is what we found out. Percentage purity is mass of pure substance divided by the total mass of the impure substance. Now, for percentage purity, in 90% of the questions, the mass of the impure substance is given in the question. Okay, the mass of the pure substance is the one that you need to find. And how do we need to find? Is based on the amount of a certain product that is formed when the pure substance undergoes reaction. Let us now look at an example to calculate percentage purity. Okay, so again, 30 seconds to read the question, and as you are reading, bear in mind that for 90% of the questions, the mass of the impure substance will be given in the question. Okay, so as you read the question, you should be able to see that you have 0.8 grams. What is this mass for? It's for your impure sodium chloride. Okay, so mass of impure sodium chloride is 0.8 grams. This is given in the question. What do we need to find next is, out of this 0.8 grams, how many grams of it is actually sodium chloride? So how do we find? The question goes on to tell you that sodium chloride had been subjected to some reaction with silver nitrate. So the reaction goes like that. Sodium chloride, when you react with silver nitrate, you will actually produce silver chloride. This is actually a salt, an insoluble salt. Now how do we know that it's an insoluble salt? Because all chlorides are soluble except for silver and lead. Okay, the question also described that you have 1.2 grams of silver chloride. Alright, so based on this mass of product that is formed, we now need to work backwards to find what is the mass of the pure sodium chloride. Now how do we do it? Again, we do it using the 3C approach. Okay, step number 1, convert to moles. Convert to moles, take note that the mass of the impure substance should never be touched. Alright, they should never be touched until the very last step. Alright, so when I say convert to moles, I refer to the number of moles of the product or silver chloride. Okay, so step number 2, compare mole ratio. Compare mole ratio between what? Between what we want to find and what is given. Alright, again, from the mole ratio we can see that it's 1:1. So number of moles of sodium chloride is actually equals to number of moles of silver chloride, which is equals to 0.00836 moles. Step number 3, convert from moles. Alright, so what do we need to find out eventually is the mass of sodium chloride that was present. Alright, so all we need to do is to take number of moles multiply by the molar mass. Alright, now that we have found the mass of the pure and the mass of the impure is given in the question, so what is left to be done is to find percentage purity, which is the mass of pure divided by the mass of impure multiplied by 100%. Okay, so before I go on to point out a very common mistake that students make, just to recap, percentage purity is the mass of pure divided by the total mass of impure. In 90% of the questions, the total mass of impure is given in the question itself, and we need to find the mass of pure. And how do we find the mass of pure? Is from the amount of a certain product that is formed. Right, so we need to work backwards to find the mass of the pure substance in the mixture. Right, and once we find it, we can use the equation mass of pure over mass of impure times 100% to find percentage purity. Now, the number 1 mistake that students make in such questions is this. When students read the question and they see a mass 0.8 grams, the first thing that students will do is to find number of moles of sodium chloride by taking 0.8 divided by the molar mass of sodium chloride. So this is the number 1 common mistake that students make, and this is wrong. Alright, so when I see this as a first step, it is immediately wrong. Right, why is that so? Because 0.8 grams is for your impure sodium chloride. Alright, meaning sodium chloride mixed with something else. So we cannot use this mass to find number of moles of sodium chloride because we don't know how much of it. Not all 0.8 grams of this solid is sodium chloride. So it doesn't make sense to take this mass to divide by the molar mass of sodium chloride to find number of moles of it. Alright, so that's why I was saying at the very start, when you see the mass of the impure substance, you should not be touching it until the very last step, which is to compute percentage purity. Alright, please bear that in mind. Now we'll look at one last practice involving percentage U and percentage purity. For this question, it involves the reaction the thermal decomposition of copper 2 carbonate. Right, so when you heat copper 2 carbonate, it actually undergoes decomposition to form copper 2 oxide and carbon dioxide. Right, this is a very famous thermal decomposition reaction, which we will learn in the chapter of metals. And why is it so famous? Because it involves a very distinctive color change that you're expected to know. Alright, so let's look at the question. Now this question combines both percentage U and percentage purity into one. Right, so we need to take note because there are a number of values that are given. So let's try to identify what are these values. Now 12.4 grams. If you read the question carefully, it is the mass of impure. Alright, mass of impure. So we need to use this when we compute percentage purity. Other than that, we are not supposed to touch this from the start. Alright, so on heating, you produce 7 grams of copper 2 oxide. This is the mass of product. Alright, and if you understand the question correctly, this is the actual mass of product that is formed. Okay, and as you read more, you will find that there is 11.2 grams. What is it saying? It's saying that out of the 12.4 grams, 11.2 grams is actually pure copper 2 carbonate. So this is the mass of pure. Right, after we have clarified what each value stands for, the computation becomes quite simple. Alright, it makes sense now to compute the percentage purity first. Why? Because we have the mass of pure, which is 11.2, and we have the mass of impure, which is 12.4. So we can easily find the percentage purity. Which is 90.3%. Okay, next we want to find the percentage U. We are given the actual mass. So now we need to find the theoretical mass. And how do we find the theoretical mass? Again, is by using the 3C approach. Step number 1, convert to moles. Alright, so we need to find what is the actual number of moles of copper 2 carbonate that was present. And for that, we take 11.2 divided by the molar mass of copper 2 carbonate. Okay, so next, step number 2, we need to compare mole ratio. Compare mole ratio between what we are given and what we need to find. Alright, so we need to find the actual amount of the amount of copper oxide that should have been formed. Alright, so we need to compare mole ratio. Again, is 1:1, so number of moles of copper oxide will be the same. And step number 3, convert from moles, convert to the mass of copper oxide or copper 2 oxide. So okay, so we get 7.23 grams, and that is the mass of copper 2 oxide that should have been formed. So then we can go on to find percentage U, which is the actual mass, which is 7, over theoretical mass times 100%. Which is 96.9%. Okay,